Hello. This meeting, as this has already been said, but I'll repeat it anyway, memorialises Alfred Whitehead, Professor of Mathematics at Imperial College 1914 to 1924, and Sidney Chapman, Professor of Mathematics here 1924 to 1946. Both were great men and great mathematical thinkers. Now the 29th of January has been said, is the date of Chapman's birthday, so I therefore have the great honour to share my birth date with him, and with another of our great ex-Maths Department staff members, the mathematical physicist Abdus Salam. Now the title of my talk is From the Arithmometer to Electronic Arithmetic. And I'll show the evolution of maths teaching from the 19th century manual arithmometer to the building of an automatic machine by staff here in the 1950s. An important part of any department is the people who shape it by their interests and personalities. The maths department has had its share of these over the 100 years of which I will speak, and I'll pay a special attention to Whitehead and Chapman and their work. Now, I always remind audiences when I do these talks that my information comes from the files. Now, your perception of what went on is going to be different. Now, I'm always glad to hear about this. So I'll leave slips with my contact details on at the coffee break. So if anyone wants to send me anything after consideration, please do so. In 1926, Hyman Levy, Professor of Mathematics here, wrote in the annual student journal, The Phoenix, "A mathematical department within an institution such as the Imperial College naturally fills a part different and distinct from that of almost any other mathematical department in this country, and this must still be so today. In the course of this meeting, I'm sure the point will be demonstrated." The history of the department includes many eminent teachers and innovative teaching methods, which are still hallmarks of Imperial College and were of its constituent colleges. Now, it's with these constituent colleges that the story begins. For those unfamiliar with the background to Imperial, I'll give a brief resume, and I apologise to those who have heard this before, but please bear with me. The constituent colleges of Imperial, at its foundation in 1907-8, numbered 4. They were all science and engineering based, and the medical side did not develop until 1988. Can you put the overhead on, please? Because a lot of this is quite complex, I've prepared an overhead. You have got a sheet, but I thought I'd leave it on because it gives you a chronology to base things on a bit. In 1845, the Royal College of Chemistry was set up in Oxford Street. And this is now a shoe shop, actually, but the facade is obviously different, but the building exists. And it backed onto Hanover Square. And the College of Chemistry was subsumed by the School of Mines, which opened in Jermyn Street in 1851, and this is now Simpson's department store. I don't know if this is significant, they've all turned into shops. And in 1872, most of the departments of the Royal School of Mines moved to South Kensington to the Science Schools building, which is now the Henry Cole wing of the V&A. The Royal College of Science developed out of the Royal College of Chemistry and the Royal School of Mines in 1881. In 1885, the Central Institution, or Central Technical College, of the City and Guilds of London, later to be called the City and Guilds College, I told you it was complicated, joined Imperial in 1908, and that was a year after the formation by the other constituent colleges. Between them, the colleges covered all science and engineering subjects, sometimes with duplication long after the formation of Imperial. This is the case with the maths department, as I will explain. Maths was taught as part of the mining and mechanics courses in the School of Mines and later the Royal College of Science, and it was taught as part of the engineering courses at the City and Guilds College. Eventually, a scheme was introduced to merge the teaching and introduce a college-wide maths department, but it was not until 1951 that mechanics was dropped from the title. I'll first discuss the teaching and teachers of the School of Mines and the Royal College of Science, then the City and Guilds College, and then discuss the merging into one department. The early background to the department has almost been entirely in the applied side of mathematics, not as a separate subject, but part of the teaching of mechanics. In the early days of the constituent colleges, mathematics didn't appear on the syllabus at all. It was taught as a necessary part of the subject of mechanics. It was not until 1881 that maths was taught as a separate subject. The first mechanics lectureship was in the Royal School of Mines, and the first post holder was Robert Hunt. his full title being Lecturer in Mechanical Science with its application to mining. This was a part-time post for the first 43 years of the existence of the colleges, and it must be remembered that the academic structure we know today didn't exist then. Many of the men involved in the early days of the constituent colleges were struggling to make a name for themselves as scientists and university teachers before the professionalisation of the field. And this period was the beginning of the end of the gentleman scientist or scholar. But it was still necessary for ambitious academic men with no private income to hold several posts at once to make a living. Now, Hunt's background was in chemistry, but he came from the mining districts of Cornwall, where he'd set up a mechanics institute to give scientific teaching to working miners. So this again was the era of self-improvement, when such institutes proliferated and itinerant lecturers plied their trade amongst the working people. The government-sponsored School of Mines, which was contemporaneously described as an experiment in popular education, was therefore the right place for Hunt. But the take-up of student places by the mining districts, which had requested a national training college, was very low. His first lecture was attended by 36 students, not all of whom were matriculated. Many were members of the armed forces, allowed to attend individual courses casually at a reduced rate. It was many years before numbers of regular students increased. In 1851-2, he gave a course of 40 lectures, which were actually an introductory course to physics and applied maths as well as mechanics. In order to enter the college, students were at first required only to have had a sufficient education to enable them to follow the courses. They did not study for a bachelor's degree, but for the associateship of the School of Mines, and after 1881, of course, for the Royal College of Science. Later students could gain both the University of London BSc and an associateship by taking 2 different exams and by registering as external university candidates. In 1925, this was altered so that the 2 exams were effectively merged for the award of both qualifications. In 1852, the immensely popular Lectures to Working Men series was instituted, at which all the professors of the school gave a series of lectures on their subjects in the evening. The working men were true artisans, and the courses given were described as uncompromisingly scientific. The courses Hunt and his successor Willis gave were the same as those to today's students, as were those in other subjects. The Lectures to Working Men was another aspect of the government's experiment in education, and the one which paid off the soonest, as for almost the next 50 years, the weekly lectures were attended by capacity audiences of 600. This is the lecture theatre in the Royal School of Mines. It's the only pictorial representation that I've been able to find. I'm doing a PhD on the Lectures to Working Men, and I've just been very lucky to get this, and it's simply an etching done in the Illustrated London News. And this is a glimpse of the prospectus that they had in the 1850s with the Lectures to Working Men mentioned. From 1853, Hunt was made lecturer in physical science, but after 1854, he concentrated on his job of keeper of mining records, producing the annual mineral statistics for the government. Hunt was succeeded as lecturer in mechanical science by Robert Willis in 1853. Willis held this post simultaneously with that of Jacksonian Professor of Natural Philosophy at Cambridge. And his book of 1841, Principles of Mechanics, was the earliest to develop the science of machines from the kinematic point of view. Willis didn't develop the maths course or the mechanics course significantly during the 15 years he held the post, and he resigned in 1868. The title of the post was then changed to Professor of Applied Mechanics and was taken by Thomas Minchin Goodeve in 1869, and he held the position for 25 years, retiring as head of department in 1894. Previously, he'd been Professor of Maths at King's College, and he also was called to the bar in 1862 and had a successful law practice, mainly in patent cases. Goodeve had amassed many pieces of apparatus and teaching models, which he had little space for in the School of Mines in Jermyn Street, but the building to the Science School's accommodation in South Kensington allowed him to develop it further in more extensive accommodation. This is Goodeve teaching, and you can see the students don't look terribly interested, but there's an awful lot of equipment and things about for them to distract their attention. A demonstrator was appointed to assist with the apparatus at lectures and to instruct the science teachers in training during the summer months. The Science Teachers in Training course was another government development in education for the masses, and the one made most well known by H.G. Wells. Now, he did very well in T.H. Huxley's biology classes, but miserably in physics and mechanics. Lectures for the regular students were still mechanics oriented, with those who were studying for the associateship of the School of Mines taking the course in the first term of their second year, before dividing in the third year into their specialisms of mining, metallurgy and geology. The introduction of practical teaching or class instruction was an innovative one, made possible in part by the space available in the Science Schools building. Previously, students had been given lectures and watched experiments being performed, although, as I've said, teaching rooms did have diagrams and things on them. In October 1881, the department was reorganised and renamed the Division of Mechanics and Mathematics, and this is when separate maths classes began. P.T. Wrigley was appointed instructor in mathematics in 1881 and was assigned a demonstrator and assistant instructor. Wrigley apparently had disconcerting habits for students, such as his ability to write on the board while standing with his back to it, and at times fixing on one student for signs of comprehension. I'm sure none of you do that. This slide shows Wrigley teaching and the room with instruments and charts round it, as I've described before. By the late 1880s, all divisions took mathematics in the first year at a fee of £3 per term. Mechanics was still pervasive in the second year, and instruction in mathematics and descriptive geometry was given, quote, as far as may be necessary throughout the session at £3 per session. In the third year, the students could specialise in mechanics, which included mechanics part 2, £8, mathematics at £3, machine drawing £3, and in the second term, mechanics part 2, part 3, £8, mathematics £3, and machine drawing £3. So they're very mercenary in those days. The maths course was divided into 4 parts, A, B, C, D. All associateship students had to qualify an A and B by the end of their second year. The syllabus was elementary algebra, geometry and trigonometry. Students taking the associateship in mechanics or physics had also to qualify in Class C algebra, trigonometry, including de Moivre's theorem, plane coordinates geometry, including conic sections, elementary solid geometry, treated geometrically, and mensuration of regular solids, such as the sphere, cylinder, pyramid and cone. Class D was also of value to them, so they had to study, but not necessary to pass in, differential calculus, including partial differentiation, and plane differential geometry, and elementary integral calculus. Class E was added in 1892 to 3, which was coordinate geometry of 3 dimensions, including the curvature of surfaces, and differential equations, including simple partial differential equations. On the retirement of Goodeve in 1894, the opportunity was taken to appoint a full-time professor for the, quote, important courses of study in mechanics and mathematics. John Perry was that professor. He had previously worked in Japan with a colleague at the Central Institution, W.E. Ayrton, who was a physicist and electrical engineer. Together, they had revolutionised science teaching in Japan and brought the same vigour and modernity to courses at the Royal College of Science and the Central Institution. They published 56 joint papers between 1875 and 1891, and Perry's 2 books of 1897, The Calculus for Engineers and Applied Mechanics, were well-known classics. Apparatus described and drawn in the latter was sent to pioneering science teachers around the country and was eventually produced commercially. This is an Ayrton and Perry ammeter, which is in the college archives. As early as 1870, Perry had introduced practical teaching with a block and tackle to his classes at Clifton College, Bristol. He continued to develop practical and experimental work throughout his career, something not previously usual in applied maths teaching. He also sent his Royal College of Science students to work in engineering shops during the summer vacation. One of his main practical innovations was the introduction of squared paper to students of maths and mechanics. Nowadays this sort of paper is taken for granted, but in 1876 it was very expensive and used only for specialist work. The use of this apparently helped Perry in his quest to break down the barriers between mathematicians and engineers. In 1897-8, Dr. Willis gave lectures on some parts of Thompson and Tate's natural philosophy, and Perry wrote, "The earnest work of the students who attended this exceptionally advanced course has well repaid Dr. Willis for the trouble he has taken in preparing these lectures." Willis also gave quite advanced lectures on hydrodynamics and electromagnetism. He apparently had a very monotonous voice, perhaps due to a slight stroke, which students always recognised by the pulsating drone that pervaded the corridor when he was talking, but it didn't affect his mental powers. Space is a perennial problem in universities, and Perry soon complained that the maths area in the science school buildings was inadequate and affected the health of the students, as they were crammed into a lecture room which was also used as a classroom, drawing office and laboratory, despite, Perry felt, being unsuitable for all functions. Very little was done about this, as you can imagine. Some little space was allocated to Perry, but he still continued his campaign, because then he had rooms split up and considered it a serious evil to the work of the division. However, Perry was a well-liked teacher, and his lively style captured the students' interest. John Wilson, a third-year student of 1910, reminiscing in the student journal The Record in 1961, wrote of Perry that his students were devoted to him, and his entrance to the lecture room were greeted by crashes of desks and pedal applause. Wilson continues that Perry was never still during lectures, and his blackboard notes and diagrams jumped from one side of the long board to another. And one of the things that he was particularly keen on was starting classes early in the morning, but he was never timetabled to do this, and he felt that it would have been advantageous to maths students to start at 9 rather than at 3 when they were tired. So we've been in the V&A building, the Science Schools building, and now, meanwhile, across the road at the Central Institution, which is on the site of the Mech-Eng building now, there was a professional mathematician teaching maths. This was Aulus Henrici. He taught at University College in various guises from 1870 to 1884, and then from 1884 to 1911 held the chair of mechanics and mathematics at the Central. He fulfilled the requirements of the post as stated in the scheme for the organisation of the Central Institution, as he was able to give practical instruction in the application of mathematics and mechanics to the solution of engineering and physical problems. Students were to gain a knowledge that should be in advance of any applications of such knowledge as they may be required to make. And from the first, entry to the Central was by examination. Henrici organised a model mechanics laboratory, introducing methods for accurate measurement not previously available, and invented a space notation for frames and stress diagrams. He produced mathematical models, as you see here, which again are in the archives, and invented a harmonic analyzer for representing the equation of a curve in the form of a Fourier series. This is a Fourier analyzer, which is also in the college archives. Henrici was a very popular teacher, often cheered in his lectures by enthusiastic students. His lecture courses included elementary and advanced topics, covering, for example, spherical harmonics, rigid dynamics, and electromagnetic theory. He greatly introduced the introduction of methods of vector analysis into Britain, and he could draw freehand circles of any radius on the blackboard and swing a blackboard on a horizontal axis, stand behind it, and draw integrate diagrams upside down so as to be the correct way up for the class to view at the moment of the drawing. Two of his drawings are shown here. I'm afraid they're a bit faint, but they're faint drawings. But it just shows some of what he could do. Perry, Henrici's counterpart, who was an engineer rather than a mathematician by training, had introduced into the Royal College of Science courses effective changes in subjects and teaching methods, continuing Goodev's system of placing the emphasis on maths rather than on mechanics. But both Perry and Henrici were to be retired after the reorganisation of maths teaching in the Imperial College to become one department. Both had renowned international reputations for their research work and were honoured by the Royal College of Science and the City and Guilds College respectively with medals and prizes in their names to be awarded annually. Perry recommended in 1911 that the maths department of the Royal College of Science and its courses be rearranged from the foundations. This would include lengthening the course of maths and removing the requirement for the students to take the courses in chemistry and geology, as his students didn't need them. In 1912, a governing body subcommittee was set up to consider the question. This consisted of representatives of the governing body and of the City and Guilds College delegacy. They took evidence from the teaching staff of the maths departments, and after consideration recommended that one maths department for the whole college should be organised, with a chief professor overseeing the whole, who should be a man capable of teaching the highest branches in both pure and applied mathematics. Perry was to be retired, having passed the usual age. He protested, but to no avail. Andrew Russell Forsyth was appointed Chief Professor of Mathematics on the 13th of April 1913. He had been Senior Wrangler at Cambridge in 1881, then Professor of Mathematics at Liverpool, returning to Cambridge as a lecturer in 1884. He was the author of many famous books, including Treatise on Differential Equations, and introduced continental thinking on the subject to Cambridge. His most influential work was the theory of function, which was said to have changed the face of Cambridge maths, and was the most important work in British maths since Newton's Principia. Forsyth was clearly a forward-thinking man, too much for the Cambridge of that time, and when he formed a relationship with the wife of a colleague, C.V. Boys, and subsequently married her, he had no choice but to leave Cambridge. C.V. Boys was actually a demonstrator and lecturer in physics at Imperial 1881 to 1897. So after a short time in exile at the University of Calcutta, Forsyth took the post of Chief Professor at Mathematics at Imperial. He immediately set about raising the status of maths in college and got it recognised as a subject in its own right for the associateship. A new chair of applied mathematics was also introduced as part of his initiative, and he recruited A.N. Whitehead from Trinity College, Cambridge, to this. He was also successful in introducing the post of assistant professor, equivalent of reader today, and got 2 staff promoted to lecturer grade from demonstrator. But the proposal that the Royal College of Science Mechanics course be amalgamated with the City and Guilds engineering course wasn't accepted at that time. The First World War held up further innovations in the courses and led to cramping again of the buildings because the Officers Training Corps and the Air Force occupied part of the science schools buildings. But Forsyth pressed on with positive changes, such as further promotion of staff to assistant professors and the new appointment of Hyman Levy to assistant professor. Levy was later to be head of department. Forsyth was a very good teacher, but Herbert Dingle, who was a physics student here then, described him as being autocratic and unwilling to assist students with problems, referring them instead to his demonstrator. This is just a maths notebook from 1914, just to show you something of what went on. It's by J. Ellingham, who ended up being a reader here. In 1921, 2 years before his retirement, Forsyth gave what has been described as the last of his displays of manipulative virtuosity by calculating the differential invariance of quadratic differential forms in 4 variables. Some of his greatest works were written after retirement between 1927 and 1935 on the calculus of variations, the geometry of 4 dimensions, and the intrinsic geometry of ideal space. This is Forsyth with his staff. The man on the end at your right is Sillick, who fell out with Chapman or whatever, or the other way around, and was banished to the School of Mines. But we'll get to that later. On Forsyth's retirement in 1923, Alfred North Whitehead was appointed Chief Professor, but he held the post for only a year, resigning to take up a chair, especially for created for him at Harvard University. But first I'll describe Whitehead's life and career. He was born in London in 1841. Between 1885 and 1910, he held a lectureship at Trinity College, Cambridge. His Royal Society obituarist describes him as showing in his teaching a philosophical urge to grasp the nature of mathematics in its widest aspects, which led him to study what were then considered out-of-the-way branches of maths, such as non-Euclidean geometry, a notion not thought of by students nor their schoolmasters at that time. During the early years of the 20th century, Whitehead worked on the Principia Mathematica with Bertrand Russell, who had been a student of his. This was intended to be completed in 4 volumes, but only 3 were written between 1910 and 1913. The volumes add up to around 2,000 pages and represent a huge amount of work and development of thought by Whitehead and Russell. And they set out in this to prove that mathematics is a part of logic, though it has been said that professional philosophers suggest that the real result of the work of the Principia was to reduce logic to a branch of mathematics. Their interests began to diverge, and Whitehead describes their collaboration as coming to a natural end. Whitehead had taken the Royal College of Science chair of applied mathematics at the suggestion of his old friend Forsyth, and during the time of his tenure, 1914 to 24, developed his work away from logic and the foundations of pure maths to metaphysics and the philosophy of science. Hyman Levy supposedly said he never understood why Whitehead had been appointed to the RCS post. I suppose this was given his interest. To Whitehead, philosophy was simply the search for the path for the pattern in the universe, and he saw the use of it as to maintain an active novelty of fundamental ideas illuminating the social system. He was much influenced by the philosophy of Henri Bergson, an early 20th century French philosopher, coming to believe Bergson's view that change is the primary reality. Whitehead believed that the ultimate components of reality are events. He rejected the Newtonian view that space and time providing a stage on which ponderable bodies continuously perform. He continued working on process metaphysics between 1914 and 1919. Einstein was another of Whitehead's influences, but Whitehead didn't accept the general theory of relativity. He developed an alternative theory in his book of 1922, Principle of Relativity. Here he shows his theory is based on a uniform time-space metric and a non-uniform gravitational metric. In the 1950s, it was regarded as one of the more important Lorentz invariant theories of gravitation. Two other important books he wrote whilst at Imperial are An Inquiry Concerning the Principles of Natural Knowledge in 1919 and The Concept of Nature in 1920. Whitehead evolved new words to explain what he meant in his writings, as he felt ordinary language inadequate to explain his ideas. He says, most of the muddles of philosophy are, I think, due to using a language which is developed from one point of view to express a doctrine based upon entirely alien concepts. An example of a word he invented is prehension, which rolls together the words perception and relation, and signifies that one actual entity grasps other actual entities into a unity. Much of his writing is very dense, and the difficulties in understanding it and his lectures, experienced by some students, is exacerbated by the language he devised. And it has to be remembered that to many of his audience, some of the lectures were on metaphysics, not mathematics, so they got slightly bemused by things. He was also greatly interested in the general principles and objects of education, and published a book in 1917 entitled The Organisation of Thought, Educational and Scientific. And the title of his address as President of the Mathematical Association in 1916 was entitled The Aims of Education, a Plea for Reform. And he felt that people had to be taught that the aim of education should be useful to the recipient for his future place in society. And he stated, education is the acquisition of the art of the utilisation of knowledge. And he was also interested in contemporary social problems and intended that his researches would benefit mankind by assisting in the understanding of life. He was a systematizer, working in systems which he felt could explain experience objectively. Whitehead was a kindly though somewhat absent-minded man and a great family man. In 1890 he married Evelyn Wade, who was the niece of the great China scholar and diplomat Sir Thomas Wade. The First World War was to impinge on the Whiteheads greatly in the loss of their youngest son, a pilot in the Royal Flying Corps, who was shot down in France in 1918. In 1924, as I've said, Whitehead resigned to take the chair at Harvard. Towards the end of his life, he had been recognised as the world's greatest living philosopher, which was an immense achievement. He had been president of several societies, including the Mathematical Association, and was Sylvester Medalist of the Royal Society in 1925, and awarded many honorary doctorates internationally. He was awarded the Order of Merit in 1945 and died on the 30th of December 1947 in Cambridge, Massachusetts. It was during the period of Forsyth's and Whitehead's professorships that the Maths Department began to be seen as an advanced mathematical and scientific research department at postgraduate level. And it was in this state when Sidney Chapman was appointed to succeed Whitehead in 1924. This is obviously a much later photograph of Chapman. Chapman was born in Eccles, near Manchester, on the 29th of January 1888. He came to Imperial from the Bayer Chair of Applied Mathematics at the University of Manchester, where he had been since 1919. Starting as he intended to go on at Imperial, he introduced new material, and during his first year gave a special lecture course on the special theory of relativity and the kinetic theory of gases. Innovation continued apace until his resignation in 1946. The reorganisation of the maths teaching had still not been resolved by 1925. Therefore, the then rector, Sir Thomas Holland, convened another committee of the governing body and the City and Guilds delegacy to try to resolve the matter. It was the intention to place all maths work in the RCS, leaving the teaching of engineering mechanics to the City and Guilds College. Chapman was in favour of this, but W.E. Dolby, the professor in charge of engineering at City and Guilds, was vehemently opposed to the idea. So it was agreed that City and Guilds staff could be called upon to teach in the RCS, but they were still their staff, and that all first-year maths courses were transferred to the RCS. And it wasn't until 1934 that the transition to a single maths department under the RCS was complete. Internal politics and personality clashes can wreak havoc in an otherwise orderly system, and so it was that the single department was delayed so long, and it has to be said that Chapman added to this complication thus. He apparently disliked Assistant Professor Sillick so much that he agreed to a suggestion whereby 3 members of the maths department, including Sillick, were removed to teach engineering mechanics to mine students in the Royal School of Mines. This was a retrograde step, particularly as Chapman was so keen on a centralised department, and does seem out of character. This is Chapman with his staff in 1935. Chapman introduced many changes into the department, including postgraduate teaching and enabling junior members of staff to undertake research. This is how William Penny was able to undertake advanced work with E.D.L. Kronig, an assistant professor. They produced an important piece of work on the first exact equation for electrons moving in a crystal lattice described by a model potential. Professor Brian Coles, later the physics department, informed me in 1992 that this Kronig and Penny model was still given in all standard textbooks of solid-state physics. Penny had started his mathematical career as a student at Imperial in 1927 and gained his PhD in 1931. He was appointed to the assistant professorship in 1936 and remained at Imperial until 1946. During the war, he was principal scientific officer at Los Alamos and subsequently, as you will know, chairman of the Atomic Energy Agency and later rector of Imperial. Under Chapman, the syllabus began to develop into the modern form of the 1950s, and student numbers increased. Hyman Levy was able to report in the Phoenix in 1926 on the wide range of topics the department taught and researched in. He stated that the department naturally separates itself into 2 groups. In the first place, investigations are encouraged with a view to devising mathematical methods of such a nature as will enable the physical or chemical problem, not the mere mathematician's idealization of it, to yield to calculation. Hence the evolution of a mathematical laboratory, founded primarily on the assumption that the study of such practical problems can be approached mathematically from the experimental standpoint. This may be regarded as the purely mathematical side of the department, albeit of an eminently practical nature. In the second place, in the field of applied mathematics, commonly so called, investigations are proceeding on a number of distinctly modern developments. For example, he mentions the modern theories of crystal structure are being subjected to tests by the detailed consideration of some of the properties of crystals that must follow from the theory. He continues with the list of tidal and other worldwide oscillations of the atmosphere, diurnal variation of terrestrial magnetism, and examination of the classical theories of elasticity and that of hydrodynamics, and it seems likely that many of these topics were influenced by Chapman's interests. Chapman was a man of very wide interests and abilities, which he continued to develop to the utmost of his powers until his death at the age of 82 in 1970. The Times obituary described him as both a legend and a scientist. In his second year at Cambridge in 1910, he became Wrangler and then researched into pure mathematics under G.H. Hardy, until taking the position of Chief Assistant at Greenwich under the Astronomer Royal Sir Frank Dyson between 1910 and 1914. He returned to Cambridge in 1914 as maths lecturer at Trinity. From 1919 to 24 was at Manchester, and then from 1924 to 26 was at Imperial. He made contributions to stellar dynamics, meteorology, terrestrial magnetism, which he renamed geomagnetism, writing one of his best-known books, Geomagnetism with Julius Bartels in 1940, and the kinetic theory of gases. In 1916, Chapman published a completion of the theory of non-uniform gases so as to give exact formulae for the various transport coefficients for a simple gas. He extended this in 1917 to a gas mixture and predicted the phenomenon of thermal diffusion. This was demonstrated by Doutzen in 1916 and was seen to have valuable technical applications. One of his most important books was The Mathematical Theory of Non-Uniform Gases, written with T.G. Cowling. This was published in 1939. One of his addresses as President of the Royal Society, 1932 to 34, entitled The Gases of the Atmosphere, included his postulation on what might happen if a hole could be made in the ozone layer. He was a man very far in advance of his time. During his long career, he gained an international reputation, and he was visiting professor at Istanbul and various other places. He worked with a Japanese geophysicist and the last of their joint works was published posthumously in 1972. He also took up research posts at institutions such as the Geophysical Institute of Alaska and the High Altitude Observatory at Boulder, Colorado after his retirement. He wrote and co-wrote 460 papers and articles and several books, and was a member of 20 learned societies and president of 8, including the London Mathematical Society and the Mathematical Society, and received the Royal and Copley Medals from the Royal Society. He was also at various times president of several international bodies, including the Commission for the International Geophysical Year, International Union of Geodesy and Geophysics. He also received many honorary doctorates from British and foreign universities and was enormously influential in the scientific world. In 1956, when he was made a Fellow of Imperial, the orator said of him, "Chapman's magnetism is personal as well as terrestrial, and his mental activities are astronomical. It would be wrong, however, to assume that his distinctions are merely academic. Indeed, he is reputed to be the only living professor emeritus who has crossed the American continent on a pedal cycle." And he had cycled from Montreal to Washington in 1939 to attend a meeting of the International Geophysical Union. During the First World War, Chapman had taken a pacifist stance, but prior to and during the Second World War, he worked so much against Hitler's regime by supporting refugee scientists that after the war, to his delight, he discovered he had been on Hitler's blacklist. Charles Brinson, reader in German language at Imperial in the Humanities Department, has researched into this pre-war period and describes Chapman's activities in a forthcoming publication. During the war, he assisted those who reached London with housing and work whenever possible, and his scientific war work included working with G.I. Finch of the Chemical Engineering Department on incendiary devices and at the War Office on military operational research. Much of his later work at college was facilitated by the use of a holorith machine with which to do his complex calculations, and this necessitated the employment of a team of young women as computer assistants. Chapman's manner was reserved but not standoffish, and he was much more approachable and willing to help students than they always realised. He was greatly assisted by his wife, Catherine Nora. They had 4 children, and the family welcomed students to their home in London. It has been said there was a simple directness about his mode of expression, which often concealed deep thought. Chapman resigned in 1946 to take up the Sedleyan Chair of Natural Philosophy at Oxford. Professor Levy succeeded Chapman as head of department in 1946, a post he held till 1955. Just as his predecessors were innovative, so was Levy. He introduced numerical analysis into the undergraduate course, and topics such as the numerical solution of differential equations and calculus of finite differences became part of the syllabus. Student numbers continued to increase after the war, rising to a first-year intake of 20 to 30 a year by 1955. I just thought I'd show you these slides as a reminder of how things used to be done before computers. And all these instruments are in the college archives. And they were all used by people in the, well, you might still use one of these, yes, but they're all actually used by people in the departments. In 1948, work was begun on an automatic calculating machine, that is one able to perform complex calculations without human intervention. So the Imperial College computer engine was built by R.A. Brooker, S. Michelson and K.D. Tocher, being completed by the latter two in 1951. The 1950s saw many changes and the expansion of the department's facilities, such as the library, which also gained a new grant, which allowed the expansion of the book stock to make it an extremely good research library. Staff appointments were made and others retired. For example, G.J. Whitrow was appointed Reader in Applied Mathematics in 1952. His title was later to become Professor of the History and Applications of Mathematics. And W.G. Bickley, the blind Professor of Mathematics, retired in 1953. The department has gone through many changes of staff, name and emphasis, as you've heard. The main emphasis had been on applied maths, which swings to and from work on pure mathematics and metaphysics. In 1951, the Board of Studies agreed that mechanics should be dropped from the title of the department, making it the Department of Mathematics. It only remained for the mechanics laboratory to be dismantled on the retirement in 1953 of Mr. Nehan, who had maintained it for 50 years, for the traces of the department's 19th century origins to be expunged. So there we have it, from the 19th century hand calculating machine, the arithmometer, to the 20th century automatic calculating machine, the ICCE. I have to say this is not the actual machine. I haven't got a slide of it, but I thought you'd be interested to see one as it's contemporaneous. Professor Levy retired in 1955, being succeeded by Professor H. Jones, as I will now be succeeded by Professor Heyman, who will talk on the department from 1956. Switch that off.